In this video, we will learn to conduct a hypothesis test for a mean when the population's standard deviation is unknown. Stopping distance is an important measure in evaluating the overall safety of a vehicle. The data in the table are a sample of 12 trials for the stopping distance when decelerating from 60 miles per hour to 0 miles per hour for the 2007 Dodge Charger. Test at a 0.05 level of significance the claim that the 2007 Dodge Charger has a stopping distance of less than 150 feet. When we conduct a hypothesis test for a mean when the population standard deviation is unknown, there are some assumptions that must be verified. 1. The sample is a random sample, and 2. Either the sample size is greater than or equal to 30, or the population is normally distributed when the sample size is less than 30. Step 1 is to state the hypotheses and identify the claim. The claim is that the actual stopping distance is less than 150 feet. So this will be a one-tailed test to the left. Remember that the null hypothesis always contains the equal sign, so the claim in this case is in the alternative hypothesis. Since this is a one-tailed test to the left, the alternative hypothesis will be that the mean is less than 150. Step 2 is to identify the critical values. Since the population standard deviation is unknown, we will use the t-distribution for our critical values. Note that we will use the second line of the t-distribution for one-tailed tests. We should travel across to the column that is headed 0.05 since this is the specified significance level for this problem. Remember that the number of degrees of freedom is one less than the sample size. Our sample size is 12, so the number of degrees of freedom would be 11. The row for 11 degrees of freedom and the one-tail 0.05 column meet at the critical t-value 1.796. Since this is a left-tailed test, the critical value will be negative 1.796 for alpha equal to 0.05 and 11 degrees of freedom. Step 3 is to compute the test value. We will use the formula x bar minus mu divided by the sample standard deviation divided by the square root of the sample size. Using the data, we will calculate the sample mean, the sample standard deviation, and the sample size. Substituting these values into the formula results in a t-test value of negative 4.489. Step 4 is to make the decision to reject or not reject the null hypothesis. It is always a good idea to visualize the orientation of the critical value and the test value by placing them on a graph of the hypothesized distribution. We have a normally shaped sampling distribution with a hypothesized population mean of 150. If the test value lands to the right of the critical value in a left-tailed test, we do not reject the null hypothesis. In this problem, we are to test at a 0.05 level of significance. We have determined the critical t-value so that 5% of the distribution lies in the rejection region. That would leave 95% of the sampling distribution to the right of the critical value. Therefore, it would be very unlikely that we would commit a type 1 error, which is to reject a true null hypothesis. But our calculated t-test value was negative 4.489. This clearly lies in the rejection region, so we should reject the null hypothesis. Step 5 is to summarize the results. Since we decided to reject the null hypothesis, our conclusion is that there is enough evidence to support the claim that the 2007 Dodge Charger has a stopping distance of less than 150 feet. In this video, we learned how to conduct a hypothesis test for a mean when the population standard deviation is unknown.